Hello everyone, here are the answers to the gift 5-3, the short one, the half sheet. I'm going to just slowly scroll through, and you'll notice that a sketch of each graph is included. And it just helps to give a nice visual and a reminder of two different ways that we can calculate these sometimes, especially when the graph given or that we create here gives us a nice geometric figure. And at any point, just email me if you have questions on any of these. So the idea is to, if you missed any of them, you can go back later, revisit this first part of the video to double check your work. And also a reminder, just be very careful with signs. We're going to get a lot of minus signs, subtracting negatives, so just be very neat, thorough, double check everything. Now there's a couple ways we could look at 7. If you remember properties of logarithms, when we get to this step, we could write it as a single logarithm. So this could just become the natural log of 5/1, which brings us to this answer. Or hopefully you remember the natural log of 1 is 0. So we do want to simplify as far as we can possibly take this. So you can see now we're getting to the point where our graphs are definitely not giving us nice geometric shapes. And that's where we want to rely on integrals to help us find those values. And as I just mentioned, not only off of this worksheet, but off of the first gift 5-3, please let me know if you guys have any questions. So now I want to take a look at what I've been mentioning so far. Evaluating an integral is a different question than finding the area, but the two could be interchanged and used to help us find the other. So we have to be very careful on what the question is specifically asking us. So our learning target, our goal for today, is to understand the difference between evaluating a definite integral and finding the area bounded by a curve in the x-axis. So from now on, if we have to answer an area question, area is back to just being positive. So area is positive always. Integrals, though, could be positive, negative, or 0. So I want to go back and take a look at number 6 from yesterday's handout. So as we're taking the integral from pi/2 to 3 pi/2 of cosine of t dt, again, the antiderivative would be sine t as t goes from pi/2 to 3 pi/2. So using the fundamental theorem of calculus, part 2, we first say sine of 3 pi/2 minus sine of pi/2. That gives us -1 minus 1, so it's -2. It kind of like interpreting velocity. The sign of the answer for the velocity is going to tell us direction, and this is kind of telling us direction with respect to the x-axis. So if our integral value turns out to be negative, then this indicates that the shaded region, or the area, is going to be below the x-axis. And that's why I also wanted you guys to sketch the graph, because we could clearly see that here, that the area bounded by the curve in the x-axis between pi/2 and 3 pi/2 sits below the x-axis. what this would mean if we were to ask for the area, here we just pretty much take the absolute value of it. So here the area would be 2 square units. We don't care where the area is, we're just going to find it. But a negative value for an integral just means if we were to graph this, we would expect that area to sit below the x-axis. All right, so let's take a look at another similar example. Again, these are two problems that look and sound similar, and one could be used to help answer the other or vice versa, but the answers are very different. All right, so first we're going to look at this integral. We want to evaluate the integral from 0 to 2 pi of cosine theta d theta. So pause the video, and based on what we looked at yesterday, go ahead and evaluate this integral. All right, so if you need more time, just pause the video again. But first we take the antiderivative of cosine. So this starts off just like number 6 did. And then that's going to be sine, but we're using theta here. So it's sine theta. S theta goes from 0 to 2 pi. And then this becomes sine of 2 pi minus sine of 0. Well, sine of 2 pi is 0, and sine of 0 is 0. So this gives us 0. So what does this tell us about our area? We know if we were to graph y equals cosine x, let's go ahead and do that, one full period. So we know our curve is going above and below the x-axis. So we're going to have portions of area that are above the x-axis and then other portions that are below. And when we get a value of 0, it's kind of like net area. Where do we have more area above or below? That would indicate a positive or a negative value. But if it's 0, this is telling us that we should expect when we go to graph this, the same amount of area is above the x-axis as is below. All right, so again, we are just graphing y equals cosine x. Again, from 0 to 2 pi. So we're looking, this part has an area that's shaded above. Going over here, this is also shaded above. And then this part would be shaded below. So these two ends should have the same area as all of the area that's shaded below. But notice we didn't find the area. We just kind of indicated it graphically with the shaded regions. So because the value of the integral came out to be 0, again, that's what this means, that we have the same amount of area shaded above the x-axis as we do below. So now for B, we want to find the area bounded by y equals cosine x in the x-axis over the interval from 0 to 2 pi. But we still have to rely on integrals here because these are still not nice geometric shapes that we could just use a formula for area. So if we want to find total area, I'm going to abbreviate this as TA, the total area, we need to do or create an integral for each portion of what's shaded here. So our first integral is just going to be from 0 to pi over 2 of cosine theta d theta. Now there's two ways to do this. We could just keep the absolute values around each part, Or any area that's below, we could just subtract it, because we know any area below is going to have a negative integral, so we could just subtract it. So now we're going to go from pi over 2 to 3 pi over 2 of cosine theta d theta. And then we'll add the area that's above next, from 3 pi over 2 to 2 pi cosine theta d theta. Now for this, go ahead and just type in each integral into your calculator. So first, just get this value, the first term, and then type in the second one, and then type in the third. So we'll use our calculators to evaluate this for us. Just saves a little bit of time. And again, you can just use an x instead of a theta. But the first value should give us a 1. And we'll subtract, and we should expect a negative value here. And this should give us a negative 2. And this last part should be the same as the first part, but still type it into your calculator. You should get another 1. And then adding these together, we're going to get 4. And since we're answering a question about area, we label this square units. So again, you could write this out as each one individually here and any area below. So we always want to graph first before we need to calculate our total area, because we have to set up the integrals. And we could either just take the absolute value of each integral here, or subtract the area that's going to be shaded below. So in the same way, physics-wise, this is like calculating the total distance traveled, which we're eventually going to do as well using integrals here. All right, so let's try another example based on area now. So we want to find the area bounded by the curve y equals 4 minus x squared and the x-axis over the interval from 0 to 4. So if you notice how I have my coordinate plane set up here, make yours look very similar, mainly because we have to go over to x equals 4. So we want to make sure we have enough room. So go ahead and sketch the graph of this. All right, and this is what your graph should look like. Now you didn't have to go all the way over to -2, because again, we're just looking at from 0 to 4. All right, so the area we're talking about, we're going to have 2 sections here. So we're looking at the area that's bounded by the curve in the x-axis. So from 0 to 2, the area is right here. And then we have this little piece from 2 to 4. Definitely not nice geometric shapes, so we have to set up integrals to help us find the area. So keep in mind, the area is not equal to just the integral from 0 to 4 of 4 minus x squared dx. That is not going to help us. That's going to give us an answer of net area, so we don't want to do this. What we want to do is say the total area, so we break this into sections. First, we take the integral from 0 to 2 of 4 minus x squared dx. And then since the second area is negative or below the x-axis, we're going to subtract the integral from 2 to 4 of 4 minus x squared dx. All right, so this one we are going to work out by hand. So first we want to take the antiderivative of 4 minus x squared. That should just become a 4x minus x cubed over 3 from x equals 0 to x equals 2 minus, we'll get the same expression here, 4x minus x cubed over 3 from 2 to 4. And we just have to be very careful with our work. So first I'm substituting in a 2, so this will give me an 8 minus 8/3. And then when I substitute in a 0, that's kind of nice here. That's just going to give me 0. So I'm just going to write it in here, saying that we'll just get a 0. and then minus, and then the second part is going to be a big quantity that I'm subtracting from the first part. So I need to keep the whole thing in brackets here. So next we're going to get 16 minus 64 thirds minus, and now we'll put the 2 in here, so we'll get an 8 minus 8 thirds. So carefully bringing everything out from the parentheses here, one at a time. Now, obviously, you can skip some steps here as long as you're careful enough with your signs, but this becomes 8 minus 8 thirds minus 16 plus 64 thirds plus 8 minus 8 thirds. Again, we can go ahead and combine all the integer values, which are going to cancel. I've got 8 plus 8 minus 16, so those are gone. And then I really have negative 16 thirds plus 64 thirds, so that'll give me 48 thirds, which is 16. And because we're answering a question about area, we label this as square units. So all of this area together, above and below, totals 16 square units. But now let's go back and take a look at what would the integral going straight from 0 to 4 of 4 minus x squared dx give us. So just type this in on your calculator. And you should get a value of negative 16 thirds. So because that's negative, and we go back and we look at the graph, all that is telling us is we have more area shaded below. The area below is 16 thirds square units more than the area up top. So the net area turns out to be a value of negative 16 thirds, means we have more area shaded below the x-axis than we do above. So those are the two very different answers that we would get for a similar question. All right, so as needed, go back over gift 5.3, the one I gave you yesterday. Also the FRQ is free response questions. So the two problems I gave you yesterday, continue working on them. I am going to collect them on Monday. Now they're very similar to previous free response questions that we've taken a look at. But you could still feel free to email me if you have a particular question, and I'll give you a hint on some of them as needed. So now on page 286, please try 15 through 17, 25 and 26, and then also read over pages 270 to 274, the average value of a function. Next Tuesday, I'm planning a 10-problem quiz over sections 5.1 to 5.3. So take care, guys. Let me know if you have any questions.